Alright, in this problem, we're given a set of parametric equations whose graph is the involute of a circle that you can see on page 659. We are asked to find all points of horizontal and vertical tangency, if there are any, only for the portion of the graph shown. So, we know that horizontal points of tangency are when y is not changing at all, and that vertical points of tangency are those moments when x is not changing at all. So we'll use these given parametric equations and solve for when each respective derivative is 0. Alright, so taking the derivative of the y function, be careful, for this factor theta cosine of theta, we have to use the product rule. When we set that derivative equal to 0, it's only equal to 0 when theta is 0, and then pi, and then 2 pi, and 3 pi, etc. We don't know how far we go out, so that it only includes the portion of the graph, but this is the pattern of theta values, where y theta is equal to 0. For vertical points of tangency, when x prime is 0, we have to find x prime first. Again, we use the product rule for this second term, and it's just theta cosine of theta. We set that equal to 0, and we know that this is equal to 0 when theta is 0, and then every time cosine of 0, which is at 0, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. Alright, so a big point here. Horizontal and vertical points of tangency, we cannot have both derivatives equal to 0 at the same time. Only one can be 0 and the other one cannot be 0. So when we plug these values of theta, where y prime is 0, we plug these values of theta into x and y to get our coordinates. We get, for these values, 1, 0, negative 1 pi, 1, negative 2 pi, and as soon as you get to 3 pi, we'd have a point that's no longer on the shown graph. In other words, we'd get negative 1, 3 pi, and if you look at the graph, this point is not part of the graph, so we won't include it. Okay. For the vertical points of tangency, we have the derivative. This is equal to 0 when theta is 0, or when cosine of theta is 0, which are these values. And when we plug those in, we get these ordered pairs. At 7 pi over 2, we get an ordered pair that's no longer on the shown graph. So this is where we stop. Alright, so we don't include 1, 0 because these vertical and horizontal lines of tangencies are where one of the parameters, or one of the x or y coordinates derivatives is 0 and the other one is not 0. They can't both be 0 at the same point, so we don't include that point. That will not be a point of tangency, vertical or horizontal. Our horizontal lines of points of tangency are negative 1 pi and 1, negative 2 pi, and you can verify that or confirm that or support that by looking at the graph. And the vertical points of tangency on this graph are at these 3 points, and you can also see those pretty easily on the graph.